Hello guys, welcome to my YouTube channel Physics Spins. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help these students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the third series of third part of this series of CSIR net physics 2021 paper solution. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, and also guys, please share my lecture details to your friends so that they will also be able to watch my free live lectures and they will also be benefited from it. Okay, so let's get started. So this is the third part of this series of uh, CSIR net physics 2021 paper solution. Okay. Okay, so I'm going to start. Question number first is Question number first is a monochromatic source a monochromatic a source monochromatic source emitting radiation with a certain frequency with a certain frequency with a certain frequency moves with a velocity moves with a velocity moves with a velocity v away from the stationary observer away away from a stationary observer a stationary a stationary observer a. Okay, it is moving towards another observer. it is it is moving it is moving towards it is moving towards another observer it is moving towards another observer b, which is also at rest. Okay, also at rest also at rest b is also at rest. Okay, along a line joining the two along a line joining the two along the line joining the two the frequency of radiation the frequency the frequency of the radiation, frequency of the radiation, frequency of the radiation recorded by A and B, recorded by A and B are VA and V. This is okay. The frequency. This is new A, guys. Actually, new A and new B. New B, respectively, respectively, if the ratio, if the ratio, ratio new B upon new A equal to 7. Okay, so this is given in the question. The value of V upon C, okay, velocity upon C is, okay, options are, option A is 1 by 2, option B is 1 by 4, option C is 3 by 4, and option D is root 3 by 2. Okay, so this is the question, guys. I'll read this question for you. Okay. Question is, okay, meanwhile, let me just check whether I'm audible or not, then I'll proceed further. Okay. Joining the two. Yes, I'm audible, so I'll proceed further. Okay. So, I'll read the question. The question is a monochromatic source emitting radiation with a certain frequency. Okay, so there is a monochromatic source which is emitting radiation with a certain frequency, moves with a velocity v away from the stationary observer A. Okay, so from stationary observer A, that is moving away. It is moving towards another observer. So that and that is moving towards another observer B, which is also at rest. Okay, observer A is also at rest and observer B is also at rest. Okay, so another observer B along the line joining the two. So and they are joining and line is joining them. I'll make a figure, then it will be more clearer to you. The frequency of radiation recorded by A and B are mu B and mu A and mu B respectively. Okay. And also, if the V upon mu A is given, that is 7, the value of V upon C we need to find out, guys. So this is the question, guys. Okay. Okay. So this is the case. I'll show you in the figure. So okay. So this is the observer A, guys. Okay. And here is source. Okay. And which is and radiation is emitting and radiation is moving with velocity v. Okay. And at this point is B. Okay. B. So this radiation is moving towards B and moving away from, right. So and the line and along the line joining AB. Okay, so this is the line joining AB. Okay, so they are in the same line. A and B are in the same line, and this source is also in the same line. Okay, so source is moving away from A and approaching to B, right? So this is the case. Now we have to find out this one, the ratio of V upon C. V is the velocity here. Okay, guys, you need to understand this. This is V. So let the frequency of radiation is nu naught. Okay, let frequency of radiation is nu naught. Let frequency of radiation is nu naught. So we know the formula, guys. You need to know this formula. Okay, I'm going to write it. So VA, that is okay. So this one, guys, we have been given this one. So V nu A is going to be, that is radiation. This the frequency of radiation with respect to A, right? This one, the frequency of radiation recorded by A. Okay, so the frequency which recorded A, because that is moving away, right? Which recorded A is mu A, that is mu 0. This is the actual frequency of radiation that we have already. This is mu naught, and because it is moving, we can see that radiation is moving away from A. This means away means minus, guys. Okay, uh, C minus V upon C plus V. Similarly, mu B, nu B is nu 0, and here you can see the radiation is approaching and coming towards the B, right? So it means nu 0 coming towards means C plus, okay? C plus V upon C minus V. This formula you need to understand. These formulas are important formula. This is formula based question. If you know the formula, you can easily solve this question. Okay, so this you need to understand. If frequency is moving away, then the formula is going to be nu 0 root C minus V. Okay, C, first there would be minus. Okay, C minus V upon C plus V. It is approaching or moving towards the B. That means nu B equal to nu 0 root C plus V upon A. In numerator it will be plus for approaching, and it will be minus for going away. Okay, now very simple. Now you can easily solve it. So this is the formula, guys. Okay, and v is the velocity. So this is the formula. So we can write mu A is mu 0 root C away, and both are at rest. Okay, C minus V upon C plus V. And similarly mu B, that is going to be mu 0 root C plus V, because it is approaching, right? Radiation approaching towards V. So C minus V. This is equation number 1. This is equation number 2. Now what we can do is 2 by 1. If you do 2 by 1, that is mu B upon mu A. That is going to be, this will get cancelled, right? And this is going to be root C minus V upon C plus V upon root C plus V upon C minus V. And this value is going to be, this will go up, right? So C minus V upon C plus V. Okay, C minus V upon C plus V. Or we can write, and we have been given mu B upon mu A ratio given, that is 7, right? So this is going to be 7 equal to this C minus A, C minus B. We can write like this: 1 minus V upon C and 1 plus V upon C. We can easily write it, right? We can divide by C. So 1 minus V upon C, 1 plus V upon C. Right? So from here, this is going to be 7 Here we have made some mistake, guys. This is C 2 by 1 we have done. So this is C plus A, C plus A minus C minus A, and then this is going to be C minus A, C minus B upon C plus B. Okay, so here it will be C plus B and C minus B. Okay, because we are doing 2 by 3, 2 by 1, right? So this is going to be minus and this is plus. Okay, so now we can cross. It will be 7 minus 7V upon C, 7V upon C, that is going to be equal to 1 plus V upon C. So we can take this 8V upon C equal to 6, and from here V upon C value is going to be 8 upon 6, that is 4 by 3. Okay, okay, we have made mistake. This is 6 by, yeah, this is 6 by 8, 6 by 8, 6 by 8, and this is going to be 3 by 4. Okay, so V upon C equal to 3 by 4. Which option is matching, guys? Let me check. Option C is matching. So correct option. Option C is the correct option. 3 by 4. Okay, 3 by 4. Next question, guys. Question number 2. Okay. So next question is, it's a good question, guys. Formula based question. So you just need to note down and memorize this formula by practicing questions. Okay. Next question is, this is from classical mechanics. Okay. Question number 2, and this question is, a particle a particle a particle thrown with a speed v from the earth surface from the earth surface earth surface earth surface attains a maximum height attains a maximum height maximum height h measured from the surface of the earth measured from measured from the surface measured from the surface of the earth surface of the earth measured from the surface of the earth if v is the if v is half the escape velocity escape velocity escape velocity and r denotes the r denotes the radius of earth radius of earth radius of earth then h upon r is, So ratio upon h upon r. Okay, ratio of h and r we need to find out, and options are 2 by 3, option R 2 by 3, B is 1 by 3, C is 1 by 4, and D is 1 by 2. Okay, so this is the question, guys. So I'll read it. The question is, a particle thrown with a speed v from the earth surface. Okay, so we have thrown the particle from earth surface, attains a maximum height h. So that attain a maximum height h measured from the surface of the earth. Okay, if v is the half of the escape velocity, r denotes the radius of earth, then h upon r you need to find out. Okay, h upon r, h upon r. Okay, so I'll solve it now. So I'll make a figure. Okay, so this is the earth, guys. This is earth of radius. Just give me 1 second, guys. Okay, so there is some. Give me 1 second. Okay, guys. So this is the earth surface, earth. Okay, and the radius of earth is r. Okay, so it is not looking at circular, right? Sphere, but yeah, this is circle. Okay, and radius r. Okay, and we have from this surface of surface of earth we have thrown a particle up. Okay, like this. This is the one. Okay, and it goes to particle, it goes to height h, height h from this surface. Okay, so this is the height h. Okay, so this is the condition, guys. So we have a particle we have thrown with speed v. Okay, with speed v, and it goes to up to height h. Okay, up to height h, this height, and so we have been given velocity is half of the escape velocity. Okay, and r denotes the radius of earth, and h upon r, denotes the radius of it, and h upon r we need to find out. Okay, simple thing. So since we have been given v is half of escape velocity, v, right? This is given in the question. V is the half of escape velocity, and you should know, guys, the escape velocity v is under root 2gm upon r, 2gm capital M upon r. This is the escape velocity, guys. Okay, 2gm m 2gm upon r, where m equal to mass of earth, and r is already given, that is radius of earth. Okay, this is important formula you should know. Okay, so this is the escape velocity. Now I'll put the value. So v is going to be half root 2gm upon r whole square, right? No, just this one. This is the v, guys. Okay, half root 2gm upon. So now what we are just using that conservation of energy. Okay, conservation of mechanical energy. So by conservation of energy, right? That this is going to be kinetic energy plus potential energy is total energy. Kinetic energy is half mv square, half mv square, half mv square, half mv square plus, that is, minus gmm potential energy, right? Minus capital M is the mass of Earth, m is the mass, small m is the mass of particle. Gmm upon R, and that is going to be equal to total energy. Okay, total energy of the system is, that is, Gmm upon R plus H. R plus H. This you need to note down. Okay, this is the total energy formula. If you throw the particle up to height h, then this is going to be minus Gmm upon R plus H. Okay, this one. So now v square value we have got this, right? 1 upon root 2. This, so we'll write this is going to be 1 upon 2 small m, and this is going to be root will, square of root is going to be this one, right? V square 1 upon 4 m square. This is going to be mv square, right? So this will be 1 upon 2 m. V square is going to be v value this one, right? 1 upon 4 1 upon 4 this one, gm upon r, 1 upon 4 2 gm upon r, right? 2 will cancel this 2, and plus minus gmm upon r is going to be equal to minus g capital M small m upon r plus h. Okay, this is going to be gm small m upon 4r minus g capital M small m upon r. This is equal to minus g capital M small m upon r plus h. Gmm will get cancelled. Okay, so this is the one, and now we will solve it further. This is going to be 3r plus 3h, 3r plus 3h, simple calculation, equal to 4r. Okay, this one 4r, 3r plus 3h upon 4r, and because this value is going to be 3 upon 4r, right? This minus will get cancelled. Okay, minus this minus will get cancelled. Okay, I can write this value is like this. Minus will get cancelled, or we can write this one minus 3 is going to be like minus 3 upon 4r equal to 1 upon r plus h. Minus will get cancelled, and this is 3r plus h equal to 4r. Okay, so from here this will go there, so 3h is going to be equal to r, and h upon r is going to be 1 by 3. This is the answer, 1 by 3. Okay, so which option is matching, guys? Option B is matching. Okay, so option B is the correct option. Option B is the correct option. Next question, guys. Next question is, it's a good question. Question number 3rd. Okay. Question number 3rd. Question number 3rd. Question. The volume and temperature of the volume and temperature of a spherical cavity filled with black body radiation are V and 300 Kelvin respectively. Okay, if it expands adiabatically adiabatically to a volume 2V. Okay, its temperature will be closest to okay, closest to. Options are, option A is 150 Kelvin, option B is 300 Kelvin, and option C is 250 Kelvin, and option D is 240 Kelvin. This is the question, guys. Okay, a very good question. I'm going to read it for you and then I'll solve it. Okay, the question is the volume and temperature of a spherical cavity. So there is a spherical cavity whose volume and temperature of a spherical cavity filled with black body radiation. So there is a spherical cavity which is filled with black body radiation whose volume is V and at 300 Kelvin temperature. Okay, it expands. So it expands. Okay, so if it expands adiabatically to a volume 2V, so we have expanded it adiabatically to volume 2V, its temperature will be closest to. So we have to find its temperature. Okay, so very good question. So, and simple one, formula based. So we have given V1 is given V. Okay, and T1 is given, that is 300 Kelvin. Okay, and V2 is given 2V. Okay, and T2 we need to find out. Temperature T2 we need to. Okay, so there's a formula for this. Okay, because it expands diabatically. Okay, so there's a formula, and the formula you need to note down that V T to the power 3 equal to constant. V, very important formula. Okay, V T to the power 3 equal to constant. So it means simple. So it means V1 T1 to the power 3 equal to V2 V2, okay, V2 uh, T to the power Q, right? So V1 V1 is given, right? V1 is V, and T1 is also given, that is 300 to the 300 Kelvin to the power 3 equal to V2 to V, and T2 to the power cube we need to find out. Okay, so from here we'll solve it further. So this is going to be, or we can write T2 is going to be equal to V1 upon V2 from here, right? V2 is going to be V1 upon V2, that is V1 upon 2V. We can write V1 upon 2V, V1 upon 2V cube. Okay, this cube equal to 2V into this one, 300 Kelvin to the power 3, right? So from here, this V1 is V, right? V. From here, this is going, the T2 value is going to be 1 upon 2, we will cancel, 1 upon 2 V to the power 1 by 3, and 300 to the power 1 by 3 upon 1 by 3 is 300. Okay, this one. So we'll solve it. So this to the power 1 by 3. Okay, so this value is going to be 0 0.8 into, this value is 0 0.8 into, we can just directly write this. This value is going to be equal to 0.8 into 300, and that value is 240. Next question. This is also a good question, guys. And this is question number 4. Question number 4. Question is the ratio of the ratio of Cp upon Cv of the specific the specific the specific heats, ratio of the specific heats, that is Cp upon Cv, heat at constant pressure at constant pressure and volume of a monoatomic gas, mono monoatomic ideal gas, monoatomic ideal gas in two dimension is, okay. Options are: option A is 3 by 2, option B is 2, option C is 5 by 3, and option D is 5 by 2. Okay, so this is the question, guys. So the ratio of Cp upon Cv of a specific heat at constant pressure and constant volume of monoatomic ideal gas in 2D we have to find. Okay, Cp upon Cv we need to find for ideal gas in which is in 2D. Okay, which is in two dimension. Okay, so we need so we have a formula, guys. Cp equal to f plus 2 by 2 and Cv equal to f by 2, where f is degree of freedom. Okay, f is degree of freedom. F is degree of freedom. We can write DOF. Okay, DOF. This is F. Okay, so for monoatomic gas, what is the degree of freedom, guys? What is the value of F? Okay, so this we need to know, because for monoatomic gas, for I have already taught this in my thermodynamics and statistical mechanics lecture. You can check it. For monoatomic gas, F equal to degree of freedom equal to 3 for 3 in 3D. Okay, in 3D, and F equal to 2 in 2D. Okay, and F equal to 1 in 1D. Okay, this you need to know. So for 2D it is 2, right? So this means Cp upon Cv is going to be equal to F plus 2 by 2 upon F by 2. Okay, for 2D, it's for 2D, for monoatomic gas, degree of freedom for 2D is this. Okay, so this is going to be this one. F is 2 plus 2 upon 2 upon 2 upon 2. 2 will get cancelled, and this is 4 by 2, that is 2. Okay, so 2 is the answer. So which option is matching? Option B is matching, guys. Okay, that is option B, that is option B. Okay, option B. Okay, so this is the answer, guys. I hope, guys, you have understood it. Very simple question, and these are 3.5 marks questions. Okay, guys, so I'm going to stop here today. Okay, and also, guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. And also, guys, please share my lecture details to your friends so that they will also be able to watch my free live lectures and they will also be benefited by it. Okay, okay, guys, thank you so much. Bye now.